Alright, in this video we are going to sketch some angles in radians and degrees, and we're going to look at positive and negative coterminal angles and reference angles. So let's get started. Of course, we are going to always deal with angles in standard position, meaning that the initial side is going to be the positive x-axis like this. Now, here we have 7 pi over 3. So in my mind, I immediately look at this pi over 3 and I'm thinking, okay, that's a special reference angle. So pi over 3, what does that look like? Remembering my unit circle. So if I sort of look at this and I imagine the circle that's around it. Alright, I know that pi is the top half of this. You know, pi would be like from here to here is pi. So pi over 3, okay, which is that reference angle that I mentioned, is a third of that. So if I take this top half and I basically divide it into 3 sections, okay, now those are pi over 3s. Now if I extend those lines straight through, let me do that over again, it would look like this. Okay, and I'll go ahead and put a line here too. So these sections are all pi over 3. So this will help me visualize what I'm doing, because if I want to show 7 pi over 3, then this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3. So here is 7 pi over 3 right here. Now you notice I went all the way around the circle and then some. So part of drawing this angle is showing that path with this curly path that I'm going to draw. So I went all the way around like this and then back to here. Okay, so if I just went from the pink ray to the next pink ray, that would be the reference angle of pi over 3. But this blue curve shows me that I went actually 7 pi over 3. So that would be a nice sketch of this angle. Now in a minute I will erase those guidelines that I made, but I might need them, so I won't erase them yet. So moving on to part B, find one positive and one negative coterminal angle in radians. Okay, so this 7 pi over 3 is a positive angle. So if I want to find a positive coterminal angle, that just means I could go all the way around the circle. That will give me a coterminal angle, another angle that's going to land on the exact same spot. So if I start with 7 pi over 3, okay, if I go all the way around the circle again, that's going to be an extra 2 pi. Okay, so it's a matter of what's 7 pi over 3 plus 2 pi. That'll give me another positive angle that is coterminal. Well, a little simple math. To get like denominators, I would have to multiply by 3 over 3. And so that's really going to give me, let's see, this is going to be 6 pi over 3. So 6 pi over 3 is the same thing as 2 pi. So if I take my 7 pi over 3 and I add the equivalent of 2 pi, you know, the going all the way around the circle, that's going to be 13 pi over 3. So that's going to give me a positive coterminal angle, 13 pi over 3. Okay, so keep in the back of your mind that 2 pi is equal to 6 pi over 3, because I'm going to use that fact again. So if I want to find my negative coterminal angle, you know, I think I'll change colors just so we can keep it straight. Again, I can start from my initial 7 pi over 3, But what I can do is subtract instead of add. Now I'm going to have to do this more than once because if I subtract 2 pi, which is the same as subtracting 6 pi over 3, you can see that that is going to give me pi over 3, which is the reference angle. All right, 1 pi over 3. But that's still positive. So if I want to go negative, I need to again subtract 6 pi over 3. All right, again, the reason why I'm subtracting 6 pi over 3, I'm really subtracting 2 pi. All right, I'm going backwards all the way around. So if I do this, this is like 1 pi minus 6 pi, that's negative 5 pi. So I might as well write this on the line. So negative 5 pi over 3. So there's my positive and my negative coterminal angles. So in short, if you want to get positive coterminal angles, add 2 pi. And you'll have to modify it to make it have like denominators. If you want a negative coterminal angle, subtract 2 pi. And sometimes you'll have to do it more than once until you get a negative answer. Now, as far as the reference angle, we've already found that the reference angle is pi over 3. But let me see if I can just make it really clear. So, yeah, when we drew the sketch in the first place, the first thing we did is we divided the circle into little sections that were each pi over 3. So this segment right here, this sector, that angle is pi over 3, and that is the reference angle. And so just to be clear, in general, when you're talking about reference angle, you're always talking about the angle that is formed with the horizontal, with the x-axis. So if you're in the first quadrant, then the reference angle is just going to be the angle itself. But if you are in the second quadrant, okay, so really in standard position your actual angle is like this, but the reference angle is this angle over here. All right, it's measured against the x-axis. If you are in the third quadrant, like this, okay, again in standard position this is the angle we're talking about from here all the way around to here, but your reference angle would just be the angle right here. Okay, and finally, if you're in the fourth quadrant, whereas the actual angle goes all the way around like this, the reference angle is just this angle right here. Okay, one more thing on this problem. We have to convert from degrees to radians. I said that backwards. This is radians. We need to convert this to degrees. So the conversion factor between degrees and radians is that pi radians is the same thing as 180 degrees. So when you have pi over 180, that has a value of 1 because these are really worth the same thing. And sometimes we'll use it the other way around, 180 over pi, depending on whether we want to end up with degrees or radians. So right now we have pi over 3, and we want to end up with degrees. So the way I think of it is, if we want degrees, we need to cancel out the pi. So we need to pick the version of this fraction that is going to cancel out this pi. So we really want pi to be in the denominator so that these will cancel out. So I'm going to use this second version, 180 degrees over pi. That way these pi's will cancel each other out, and that just leaves 180 degrees divided by 3. And 18 divided by 3 is 6. So this is the same thing as 60 degrees. Now, for a special angle like this, pi over 3, this is something that you should have memorized anyway. You should have memorized, for example, that pi over 6 is the same thing as 30 degrees. That's a special angle, so we have to memorize these. And pi over 3, that's 60 degrees. Pi over 4 is 45 degrees. And pi over 2 is 90 degrees. Alright, these things should be memorized. And of course, pi itself is 180 degrees. So these facts should be committed to memory. So you really shouldn't need any calculations to turn pi over 3 into 60 degrees. It should be a memorized fact. Alright, so we're moving on to problem number 2. And guys, we're going to do the same thing again that we just did, but this time we are starting with degrees. Now, looking at this negative 140, the last problem was a positive angle, so we were going in this direction, counterclockwise. But when you have a negative angle, negative degrees or negative radians, you are moving clockwise. This is the negative direction. Okay, so just keep that in mind. So we need to go negative 140 degrees. So standard position. So of course our initial side is going to be here, the positive x-axis. Now, negative 140 degrees. Now, I know if I went this far, kabam, that would be negative 180 degrees. Okay, all right, I'm going all the way to the straight line. That's like a semicircle. That's 180 degrees. So that's too far. And of course, if I were to stop here, skirt, that would be negative 90 degrees. So negative 140 is going to be somewhere between negative 90 and negative 180. So basically, I'm just going to make sure that I put my angle in the third quadrant over here. Alright, just really anywhere over here is good enough for this sketch. So, this is a decent sketch of negative 140 degrees. Okay, that's all there is to it. Now they want us to find a positive and a negative coterminal angle. Well, a coterminal angle is another angle that lands at the same position as the angle that we have. Now, imagine that we swung this ray like as if it was on a hinge right here at the origin. So if we took this ray and we swung it around the origin, all the way around and then back to where we started, can you see that that would be a 360 degree motion? So every time you go 360 degrees, you're back to where you started, so that is going to be a coterminal angle because you're going to be landing right where you were. If you go counterclockwise, that's positive 360 degrees. If you go the other way, clockwise, it would be negative 360 degrees. So the takeaway is, if you want coterminal angles and you're dealing with degrees, just either add or subtract 360. So the angle that we have to start with is negative 140 degrees. Since I want a positive coterminal angle, I could move in the positive direction by adding 360 degrees. Okay, and that happens to give me 220. Okay, so that's what you get if you go all the way around in this direction and land at the same spot. Now, if I want a negative coterminal angle, I should be able to get that by, again, moving 360 degrees, but I'm just going to move in the other direction. So, in other words, I will subtract 360 degrees and land back to where I started again. So, let's see. That looks like that would be negative 500 degrees. Okay, so this is very easy when you're dealing with degrees. add 360, subtract 360, and you'll have your positive and negative. Now, bear in mind, if they gave us a big enough angle, you might have to add or subtract 360 more than once to get a positive and a negative number. So just watch out for that. Anyway, so now we need to find the reference angle in degrees. So remember, the reference angle is going to be the angle measured against the x-axis. So the reference angle is actually going to be this angle right here where I just put the theta. Alright, the angle between here and the x-axis. So what would that be? Well, keeping in mind that, you know, if you're looking straight across like a semicircle here, this is 180 degrees total. So this portion with the blue arrow, that is negative 140 degrees, you know, because I'm traveling in this direction. Now if I went all the way, that would be negative 180 degrees. So, you know, ignoring the negative sign for a second, if I want the distance between these two, I need to say, okay, I have a total of 180 degrees here. This portion over here is 140. So the part that's left, I should subtract. Okay, so 180 minus 140 tells me how big this part over here is. So obviously that is 40 degrees. I apologize for the overly dramatic sneeze. But hey, it is what it is. Anyway, so this is 40 degrees. Now reference angles are always positive. They're always positive. So I'm just going to say 40 degrees, not negative 40 degrees. All right, and last we need to convert angle beta to radians. So again, angle beta is negative 140 degrees. So remember that pi radians equals 180 degrees. So we should be able to multiply by pi over 180 or 180 over pi anytime we want, because we are really just multiplying by 1. So you know what, 140 degrees, negative 140 degrees, just to make it even more obvious, I'm going to put the word here. So we'll think of this as negative 140 degrees. Okay, just so I can emphasize what we're doing. Okay, now what I can do is multiply by one of these things. All right, but think of this as pi radians. And of course 180 degrees. And ask yourself which one I need to multiply by. So we already have degrees, so we really need to cancel degrees out and leave radians. So that's why we want to make sure degrees are in the denominator when we multiply, so we can cancel them out. So that's why I'm going to multiply by this version. I'm going to multiply by pi radians over 180 degrees. All right, that way the degrees will cancel out and you're just left with radians. So you're going to start off with negative 140 pi over 180, dividing both of these by 10. Okay, you're going to wind up with negative 14 pi over 18. Now, dividing both of these by 2, you're going to end up with negative 7 pi over 9. So that's the measure of angle beta in radians.